Online attendees, are you there, please? Grace, Lawrence, Peter Cherise, Popola, and Junaid. Are you there, please? Okay, good. All right. Once again, first we welcome to today's session. And as we approach our final session tomorrow morning, Tejesh, take a floor and start with the training. Thank you.
Thank you so much, Emmanuel. Let me turn on my mic. I think so. You need to mute. Share this. All right. Welcome, everyone. Really glad to have you again for this session. I know this was supposed to be the last session, but I still have enough that I need to make sure that I pass on the information, I do the knowledge transfer as much as possible so that you can get the most out of this webinar, the seminar, and then apply it to your actual work, right? One more big thing is, as I was having a conversation with the folks who came in early today, was practice is the key for Revit, all right? Not necessary that you need to have a live project. There are many Revit models, architectural models available online. You can simply download them. Many a times what happens is the website where you plan to download it from will only ask you for a login credential. That's it. But make sure you utilize it as much as possible. There are a lot of resources for you to keep on practicing. You can take this as your base and then keep on practicing on top of this. All right. All right. So now with that said, in the session that we had earlier, that you had earlier in the morning today, you went through and created the HVAC floor plans. Yes. Right. All right. So now what we'll do is, now that we have the HVAC supply and return, did you guys do the return ducting as well or only supply? Moise? Only supply, right? Okay, all right. We'll talk about return ducting as well in this case, okay? So let's go ahead and open our Revit model. My screen is visible, right? Okay, all right. So let's go ahead and open our Revit model. As I mentioned, open Revit 2025. In the Revit 2025 dashboard, you will have the open under the models. Once you do that, you will find this particular window. Go to the location where you have saved your project. All right. Click on it and click open. Please make sure you follow up as well as we are progressing to the work. All right. So over here, this is something that I did last night. I just wanted to make sure that I give our instructors a good idea of what needs to be done. Don't be intimidated by this floor plan only because it looks sorted out. When you start working in Revit, it will take time for the ducts to properly show up. You will have your own philosophy. Each engineer will have their own philosophy for the design based on the experiences that they have come across, so on and so forth. Okay. But we need to make sure that we have certain minimum standards that we need to follow, right? Like yesterday, we spoke about the maximum 5 feet length for the flex duct. Please make sure that you try to apply that as much as possible. Okay. Now, we will talk a bit about sizing the ducts. Okay. I understand you might have sized the ducts with what the neck size is or what the inlet size is of the VAV box, correct? That's how you size the duct till now. Okay. Now, next thing we are going to do is we are going to size the duct based on the pressure drop that is being designed for. All right. So now let's go back to the folder that the team at Nziza Academy shared with you. So it will be something like this. All right. In here, you will have a duct sizer.zip file that you were sent with the link day before yesterday. Everyone has it? Everyone has it downloaded on their local drive? Yes? All right. So since I'm getting yes to the participants in the room, I will go ahead and make sure you extract the zip file as well. Until and unless you don't extract it, it will not show up. All right. Once you open the folder in the duct sizer, you will have these total of 5 files. All right. Make sure you have all of the 5 files. If one file is missing over here, the software will not work as desired. All right. After you go into the folder, you'll see this ductsizer.exe icon. Okay. Double click on it. It will open the duct sizer tool for you. It will look something like this. Is everyone with me till now? Online folks, you can also participate and let us know if you are with us or not. Everyone has this open? Yes? Does anyone need any help? You need help? Moise and Paul.
Moise will come back late. When the work is on his way.
He's coming?
Yeah, he's coming.
Oh, yes. Yeah. You have downloaded the link. That means you have downloaded the folder. So go to that folder. For participants, there is nothing to duct size. There it is. First, open that one. Open the right color icon. Second option. All right. Everyone back over there has access to duct sizer now? Yes. All right. Perfect. Okay, so yesterday, can you please let me know what was the CFM that we had gotten for this particular room? Somewhere around 80-85 CFM? Yes? Do you guys remember 80-85 CFM? The total ACH that we were talking about the other day? Yes? All right. So now what we are going to do is, we are going to have this particular window open for sizing the duct. All right. You can also have different types of conditions, right? You can even have the, oops. Sorry. Okay, So you can even have the units set from IPS, which is the US system, to metric. That is also fine. But right now, since we are working with the IPS system, the inch pound second system, we'll keep it to IPS. And over here, let's have this at 68 degree Fahrenheit air at standard temperature and pressure. All right. In case you are working with high altitude places, right? Like somewhere in Tibet or somewhere in what are some high altitude places in Africa? Is Kenya high, like as compared to the other mainland region? I don't know. Volcanic region, right? So basically the air starts to get thinner when you go above in the altitude, right? So it's no longer the standard temperature and pressure for the air. Okay, but most of the project Kigali is at STP, all right, standard temperature and pressure. So it will be the 68 degree air standard temperature and pressure that we will use. Now in the flow rate, you will enter the 85 CFM that we had. Flow rate 85 CFM. Does that make sense? All right. Now, let's talk a bit about head loss. Correct? We'll take an analogy again of the garden hose that we have. When we have the water go into the garden hose, the pressure at the inlet of that hose versus what we have at the exit of the hose differs, correct? The pressure is higher when there is entry point as compared to the exit point. Why is that the case? There is friction between the fluid, in this case water, and the surface of that pipe, correct? It slows down the velocity of the water, slows down the pressure of the water. Make sense? No. So the same thing is happening over here. How much pressure drop we are getting with respect to 100-foot length of duct. Okay, what this will be used with? This will be used for calculating the external static pressure that we were talking about the other day. What is that? You have an air handler, correct? You have fans in the air handler. The fans are supposed to push the air to the last possible point. In this case, our last possible point is most probably going to be this point over here. So if you don't have a fan that is sized to deliver air till the last point, most probably there will be no air coming out of that diffuser. Basically meaning that the heat loads, the ventilation, the outdoor air loads will not be met at this point. Did that make sense? Yes? All right. So now, let's go back to duct sizer. Over here, we had entered 85 CFM. Now the head loss that we are talking about, okay? This depends engineer to engineer, okay? But the usual range for this head loss is between 0.08 inches to 0.1 inches that the engineers use typically. 0.08 or 0.1 inch, or between 0.08 or 0.1 inch per 100 foot. All right. So now, as a design philosophy, I try to make it a low friction duct. All right. Now, over here, you see there are still more check boxes over here. Okay. To get the adequate size of the duct, you need to have at least two parameters that you are feeding into the duct sizer tool. It can be either CFM or head loss. If you are restricted with air velocity, you can even have the air velocity entered over here, right? But you need at least two parameters to get rest of the parameters. Is that making sense till now? spoke about the different type of HVAC systems, right? The noise criteria when we had a dual duct connection was a matter of concern. Why? Because there are different components that the air is passing through, double components that the air is passing through on the hot side and the cold side. That is the reason why we try to restrict the air velocity to as low as possible. Okay, but when you make the air velocity as low as possible, please understand your ducts are also getting bigger. Okay, if it has a lot of space to move, that air has a lot of space to move through the duct, it will not be noisy. The smaller the dimension of the duct, the cross section of the duct, if it is a 10-inch by 10-inch duct versus by a 6-inch by 6-inch duct, and you're trying to enter the same amount of air through it, the 6-inch by 6-inch duct will create more noise. Okay, that will have more velocity, that air will have more velocity, making more noise. So always make sure that you understand that the air velocity, if you are working in like let's say a patient room, let's say waiting area, try to keep it around like maximum 500 to 600 feet per minute. All right, if it is a surgery area, as it is, we are going to need laminar flows over there. Laminar flows will come into picture if you also have low velocity going through the surgical boom. We'll talk about surgical boom in some time, to ensure that the laminar flow is properly taken care of. All right, in that case, try to have your duct size for around 400 feet per minute. All right, okay. Now we will take into consideration two aspects: the flow rate, which is 85 CFM, and then we have the 0.08 inches per 100 foot. All right, now over here you will see the information that we have gotten over here, right? This automatically got filled over here, right? It says that with 85 CFM at 0.08 inches of pressure drop, if we have a 6-inch, now it is showing me a 5.8 inch diameter duct that is recommended for this particular pressure drop. If we are using a 5.8 inch duct, then the velocity of the air in that duct will be 467.6 feet per minute. We are trying to keep it, it's a patient room, we are trying to keep it around 500 feet per minute, maximum 500 feet per minute. So this is lower than 500 feet per minute, right? That is why it is better. All right. So now when we are talking about the 6-inch duct that we were using over here, this 6-inch, it will work fine. Did that make sense till? Do you want me to explain it again? Yes, no? Did the duct sizer make sense? Yes. Yes, I mean, it comes to experience as well. Then you get all from then you go back into the all right, so let's move forward. Any other questions? All right. So now we yes. Right. So the head loss, the person of I wanted to repeat the question. All right. So for the folks online, the question was: are there any parameters that affect the 0.08 inches per 100 foot of pressure drop that we are talking about? So yes, it does come into consideration. Sometimes the project will push our ducts to be different type as compared to whatever GI that we might have for a regular duct, right? The regular ducts are made up of galvanized steel, right? Or aluminum if there is budget, right? But in case of, let's say, commercial restaurants, where we need to have a heavier material for exhausting the grease from the kitchen exhaust hood, in that case, the friction will be more. Is that making sense till now? Yes. So it will depend on the material type that we are using. Now, one more thing is how many fittings we are assigning to the worst case scenario path of the duct. Over here, as I mentioned, this will eat up a lot of pressure, right? If we are talking about this duct, total duct without any connection or anything, we can calculate it at 0.08 inches per 100 foot. So if we start counting from this point, and then there is no particular duct connection over here and goes straight for 100 feet, the pressure drop will be 0.08 inches per 100 foot. Make sense? Now, you introduce an elbow over here. That will increase the pressure drop because air is taking more effort to go through that turn in the duct, right? Instead of going straight. In the VAV box, there is a damper, right? That damper will also add to the pressure drop, right? After that, we have another elbow. We have this expansion or contraction fitting. All of these have pressure drop associated with it. Okay, the fittings, when we are talking about, there is another organization called as SMACNA. Okay, Sheet Metal Contractors Association, something, Manufacturers Association of America. I don't know the exact full form of it, but it's called SMACNA. It's basically, they will give the standards for how much of pressure drop that here it will be required. I'll share that data with you as well regarding a chart for SMACNA for how much pressure drop will be in the given fitting. All right. Did that answer your question, sir?
Let's say considering that will be made in and so implemental use some form material quite
okay.
When you will be the same as when using
hard surface. So yes, you are correct. There will be hard surface in the if you are using like cast iron duct if needed, because some of the jurisdictions ask you to do that as well. So in that case, yes, as compared to GI, the upper material will be very rough. It will take up more pressure, right? So it might be somewhere in the between of 0.2 or 0.5 or something like that. All right. So going back to the chart now. The reason I was talking about the heat load calculation and everything, now all of those minimum total air changes per hour, you'll need to start counting them, and then accordingly we will size our duct, right? So now talking from the last point, over here we just have 85 CFM, correct? Now, once we do heat load calculation for this room, maybe the minimum total air changes per hour will increase, right? So now 85 CFM, and let's say this one requires 200 CFM, right? So 85 plus 200 CFM. Now what this duct is carrying at this point needs to be 280 CFM. Are you following me? Now, we enter 285 CFM over here. That means our duct needs to be 9.1 inches to follow the 0.08 inch per 100 foot pressure drop, right? But the ducts will not come in like 0.1 inches. It will usually come in 10 inch, 12 inch, 14 inch, so on and so forth, right? One more thing. Not every time you'll get the luxury of using a round duct. Most of the time you'll end up using a square duct to maximize the efficiency of the space, right? But right now, as you see, the equivalent diameter corresponds with a circle, right? So again, it is giving us a circular duct. For checking if how we can use a square here for duct size, okay? What duct size that you think can work with it. So now once I put 8 over here, the software automatically detected 9 inches. Just a minute. But again, as I said, the ducts are usually available in even inches or even mm as well, right? Full M. So over here, it will become a 10 inch. So this duct of mine needs to be a minimum of 10 inch by 8 inch. If it goes bigger, it is fine. But it cannot be smaller than that, because then we are increasing the pressure drop over it. And for 8 inch by 10 inch duct, the head loss that we are getting is 0.05, which is good because it is lower than 0.08. Is everyone with me till now? Just a minute. He had a question. I'll come back. Sorry? Okay, regarding the square duct? Yes.
So, for that things, you are done with
Yes. So I will repeat the question. So the question in house for the folks online was, over here when I enter 285 CFM and 0.08 inches per 100 foot of pressure drop, the software is only giving me 9.1 inches as the equivalent diameter. Okay. But of course, the world is not perfect. Very seldom we'll get chance to use nice round ducts, because round ducts take bigger space as compared to rectangular square ducts. So for that, making sure that we have the correct dimension for the rectangular duct, once I hit a number over here, let's say I put 90 over here, just saying, spitballing, not 90 cannot be. This other number, software will already check and assign it. Okay. So in this case, what I did was I tried to take a number close to this number. Okay. 8 inches or 10 inches. All right. So 10 by 7 is what the software, this 7, it will automatically detect. Right. But again, 7 inches is not available in the market. So just for our sanity check that our head loss is maximum of 0.8 inches, I just hit 8 in there, make it a 10 inch by 8 inch duct, which is a 0.055 inch per 100 foot head loss, which is lower than this number over here. We are fine with it. Make sense? Is everyone following? How about you guys? You guys following? Yes, for sure. Okay. Now, over here, as you see, my duct, I have sized it for 12 inch by 12 inch, which is bigger than 10 inch by 8 inch that we are talking about, right? This will also work, okay? Or what I can do is I can reduce it to a 10 inch by 8 inch over here, right? But I'll talk about this in 1 minute. the thing is, now if I make it a 10 inch by 8 inch, and then I again put a transition over here, because let's say this particular area over here, the A&E consumes another 500 CFM, right? So at this point, what the duct needs to have is that 285 CFM that is required over here, plus the 500 CFM. So that totals to a 785 CFM, right? Now, if I go back to my table over here and put 785, I am getting somewhere around like a 16 by 10 inch duct that I need. Earlier, I had a 12 inch by 12 inch, right? So now we can still keep that duct at 12 inch by 12 inch. The reason being, when we order the ducts, when the contractor orders these ducts on the field, they will also order the transitions. Like this is a transition over here, correct? It's from big, it's becoming small, right? When you have many more transition, if someone is from the contracting team over here, they might know more man hours get put into it. Man hours equals to time, time equals to money, right? So to make sure, because most probably the contractor is going to come back with the same calculation for you, saying that even a 12 inch by 12 inch is going to work. Okay. So in a given project, try to minimize the given transitions to the best possible optimization. It's not like we can have just 12 inch by 12 inch throughout the project. Don't do that. Have 2-3 transitions, but make it reasonable so that the design is optimized. This also will come into picture when we are talking about the space. Okay. Dual duct systems that we spoke about on day one, space was a big issue, right? There will be other services as well that will be running, that we'll be checking in some time in the same ceiling space. And usually the ducts end up taking the most amount of space in the ceiling, right? And in actuality, what happens is, on the construction day, when the ceiling is all set or the ceiling is all prepared, without the chipboard ceiling or the grid ceiling, the fire protection contractor will be the first person on the team to be over there. And then he will put his fire protection pipes right in the center of the given corridor. Once that happens, our ducts and our pipes have no chance of winning against them. Fire protection, fire alarm people will always have the upper hand because it entails to fire safety. All right, life safety. So we need to make sure that we understand, we keep enough space over there, and this is where Revit will come into picture. If your models are properly coordinated, later on you'll have far less RFIs, far less shop drawings to review because it is already coordinated over here. Make sense? Let's move forward. Again, I would strongly urge everyone to do the heat load calculation one by one. This is a very important thing. We have given enough priority to it. Make sure that it happens. All right. And again, go through one by one room. I know there was a brainstorming over here that we mentioned that do we need to do this one by one? Is there a rule of thumb of doing this? Rule of thumb will work okay if you are working for a hospital, for an office project, maybe a hotel project. Over here, it becomes very critical to make sure that we have the proper concepts applied. With me till now? Yes? All right. So now, one by one, we'll need to add the CFMs till it comes to this point. Okay? Does that make sense? And at this point, you will have the highest CFM because this basically duct, we are trying to take it to the air handling unit. The central air handling unit. The cold air or the cold conditioned air from the air handling unit will be coming in from this direction. Then it will split. Some part will go over here, some part will go over here, and then be delivered to the areas. All right. One more point that I wanted to make over here yesterday, but I forgot was when you are placing the diffusers, try to get it closer to the facade. Okay, we have had a detailed discussion how the facade affects, how there is heat transfer going through it. If you try to capture those heat loads right at the facade, your AC system will not need to work overtime as compared to if you have the diffuser over here, because the real heat load coming is from these two areas. And in that case too, try to center it over the windows, because as we mentioned, windows will have the most amount of heat transfer coming into a given area. Is that making sense? One word of caution over here. It is fine in areas like this to have it over the window. But when it comes to wards, be very careful if you try to have the diffusers on top of the beds over here. The patients will be sleeping over here, and if they have constant amount of airflow on their head, it will lead to illness even more. So in this case, try not to have the diffusers right over their head. Making sense till now? Very common issue that happens in hospitals. If you have a hospital, if you have a office building or a manufacturing facility, it's fine. But over here, try not to exactly center the diffusers on their head so that the cold draft air doesn't hit their head and make them even more sick. Now, talking about the return, we have supplied the air, correct? We need to return back the air to the air handler, correct? There is a supply stream, return stream. There is also an exhaust stream. Sound is not all good, right? Okay. Okay, coming back to the point, we have a supply stream and then we will have a return stream. In the restrooms, we will have the exhaust stream, exhaust ducts, right? And in the air handler side, we will have the outdoor air ducts, the 4 ducts that we spoke about, right? So now we'll do the exercise of placing even the return air grill and checking how that works, going back to this point. Okay. Now we will be taking a look into what is called the coordination aspect. Because over here, as you see, if I move this point from this section from here to here, you have these 2 ducts, right? This one duct and this one duct that are visible in this section over here. The circular duct and the square duct, right? What we need to do is we also need to route our return air ducts. Now you need space for it, right? You might need even offset for it, because as you see in the section, the ducts are already close to the top of the beam over here, right? If it was a floor plan in AutoCAD, it would look all good and fine. But then you would get a lot of RFIs and shop drawings asking what is happening actually. Now in this case, we are going to resolve it. We are not going to wait for the contractor to do the coordination. We are going to do the coordination as consultants right away. All right? With me till now? Okay. Can someone tell me how much CFM we had over here? 85. From my original presentation, is the pressurization required for this room positive, negative, or not required? Not required. Okay. Any other takers? You guys forgot? Okay, I'll tell you, it is not required for a patient room. For the operating rooms, it was positive. For the toilet rooms, it was negative. All right. We are supplying 85 CFM over here. If our register, the return air register, also has 85 CFM coming out of it, it is neutral. Same or not required. The pressurization as compared to adjacent areas is not required. You can even make it positive pressures. That is fine as well. Okay, I'll tell why positive pressure in some time. Okay, so 85 CFM is what we are getting through here. Yes, Lawrence, you're correct, not required. So 85 CFM is the supply air. Yes. For now, what we'll do is we'll check in the air terminals. You will have a return diffusers over here, right? I have shown you how to insert the family from here. There are many other families available in the market. You can use whatever is needed, but we will take care of it with the return diffuser. All right. Yes. Right. All right. So for the folks online, the question in-house was, since our room over here that we are seeing, the patient room that we are looking over here is seal packed. All right. We are assuming that the windows are not operable. It is not opening. All right. In that case, where is the ventilation air coming from? Now, we'll go back to the schematics that we had checked when we were looking at the central air handling units in the first day and second day. Okay. Okay, so this was one of the schematics that we saw on the first day. Remember this? Over here, we have different components that we were discussing, right? We had the return air component over here, the return air fan, then we have the relief. This is where our outdoor air is coming from, right? At the central air handler, right? So the air that we are getting, basically this duct that we see over here is this duct in Revit that we have drawn over here, right? So the outdoor air load, we are taking care of it in the air handling unit itself. Why we are trying to do that? We are trying to maintain that 21 to 24 degrees centigrade set point for the patient room. If you open a window and it has rained outside, the humidity has increased, and you're trying to open the window, that set point in that patient room will also increase, right? And that will differ from the standards. So over here, when we have in the presentation, as I mentioned, over here, when we have the outdoor air that is already properly treated, if you need to have some kind of dehumidification, then the dehumidification can be done at the cooling coil. If you need to raise it up, the temperature you need to raise it up, you can either do it in the steam coil or the heating coil, right? Yeah, very good. So if you open the window, so one point in the in-house attendees was regarding the quality of air, right? I'm pretty sure that Kigali does not have a lot of wildfires. You keep on hearing these wildfire terms coming from the US, right? That they have wildfires. When there is wildfire, literally the entire sky becomes orange because there is so much smoke in the air. All right. And if you come to India without even the wildfire, it becomes too smoky because we have too many diesel vehicles over there. So if you open the window and you have that type of air coming into it, think about the recovery period of the patient, right? So if we get the outdoor air through this air handler, we have one filter section and we have the other filter section, right? You remember the minimum filtration efficiency required from that table? The HEPA filter that we spoke about? That is this. Does that make sense? So does that answer your question? Yeah, from the left, what is coming is the pink color duct right? That air will go back to the air handler, right? Now, if let's say in this case only 575 cfm or no, 725 cfm or sorry, 785 cfm that we were considering for the 3 rooms. We have a question, basically clarification, that this end of the duct that we are seeing over here is this duct coming going back to the air handler, the return air duct. All right. Now going back to the presentation, in the air handler, we'll keep that air handler outside for some time because there is no mechanical space in the building for the air to be relieved. Why do we relieve the air? Let's say we just have those 3 rooms, right? Those 3 rooms that we were talking about. For this one, we had calculated it at 85 CFM, right? This one, we are assuming 200 CFM. And this one, we are assuming it to be 500 CFM. A total of 785 CFM. Okay? 785 CFM, again, we are assuming it. We have not calculated the heat load for this one, or this one. Okay? 785, we are, and let's consider only these 3 rooms in the project. 785 CFM is going back to the air handler. Okay? Let's say from the calculation that we have gotten, minimum outdoor air changes per hour, we have gotten that for these 3 rooms, we require a minimum of 50 CFM, minimum outdoor air changes per hour. Okay? So if you have 785 coming from here and we have 50 CFM again getting added to it, it will just keep on increasing the pressure of the air handler as well as what is being supplied, right? It will become too high pressure. For that reason, we are relieving some air from here so that another 50 CFM when it gets introduced into the air handler, then we have the constant air going through. Alright? That is one reason. Second reason is your coils, your fans are sized for a maximum possible capacity. If we don't have a relief and we keep on adding to this, the air CFM will just keep on increasing. Does that make sense? Does that answer your question? All. Any questions online? If any questions, please drop it in the text. We will take it. Okay, by the way, is that now, are the dots connecting now? What we are trying to do from day 1 over here? Okay. So now, let's go back over here since we are talking about the patient room. Let's use this particular return air diffuser. Click, drag, and move it over here. Click, drag, move it over. Yes. Yes. Okay, there is a very good question in the room. How about the positioning? Now what I have on my tooltip is a return air grill and this is the supply air grill, right? Now if I place my grill over here, return air grill, the air is getting supplied to the room from here, right? We checked from this presentation over here, there are 2 fans for maintaining the static pressure, right? One is the supply fan that is pushing the air out of the air handling unit. And then there is a return air fan that is pulling the air into the air handling unit. Okay. So when we go to Revit, this air that is being pushed is from the supply fan. The air that is going out from here is from the return fan. Okay. We are pushing and pulling at the same time. So if we have the diffusers right next to each other, there will be short circuit of the air. It will not even meet the heat load that it is supposed to. Okay. So in general, as I mentioned for the supply air grill, try to keep it close to the facade. The return air grill, try to keep it close to the doors, away from the supply air grills. Try to make it at least 10 feet minimum from the supply air, so that there is no short circuit going on in the room. Make sense? Does that answer your question? Yes. Thanks. Yeah, that can also be. Yes. That will also be, but again, just as I mentioned, don't try to have the supplier right on top where the end of the picture is. Try to keep it as dynamic so that the contaminants in the room can be survived. But don't repeat those or don't use it. That's try to make it on the facade side. Since over here, as you did mention, made a good point. So the one more point in the room was for the team online that how about the proper flow of the air to make sure that the air is properly utilized to exit as an exit for the contaminants, right? It should not keep on revolving in the room itself. So for that, yes, as I mentioned, try to keep the diffuser first of all closer to the facade, with the exception that it is not directly falling on the head of the patient, right? And then try to make it as diagonal as possible so that the entire room is covered with the airflow. Does that make sense? Oh, perfect. Okay, so over here we have placed our first drill, but again you see the elevation from the host is 0 feet 0 inches, right? So we'll go back to our section that we had over here. In this case, I'd rather use a horizontal section. So let's move the horizontal section. Everyone with me with this return air drill? Or do you want me to show it again? Everyone okay? Or back over there? You guys okay? Daniel? You guys okay over here? You guys okay following? Please do follow, guys. Again, this is something that you're investing time into. Make sure you understand the concepts because these are very basic concepts in Revit. Based on this, you will be able to build. There might be minor discomfort when you're learning new things, but it will help you pay dividends later on. All right, so everyone with me till now? All right, so let's go ahead and check the section view and see where the diffuser is mounted right now. As you see, the diffuser is mounted on the floor over here. Okay. Now, one thing that we were trying to do yesterday, if you remember properly, we pulled this particular supplier diffuser and we did the placement on the work plane. Right? The placement on the work plane was this first floor ceiling that we were utilizing. You remember from yesterday and today morning? Yes, right? Over here, when I tried to pull the return air diffuser, return air grill, this is not giving me any option over here. Okay. Only one option is to place on the air duct right away. Okay. The reason being there are different types of positioning. As I mentioned yesterday, I will let you know regarding what those three different types are. So over here, the is supposed to be mounted on one of the planes. Now, be that a reflected ceiling plans, it will have a plane as well. That ceiling plan will have a ceiling. You can mount it on that. You can mount it on a vertical face like this on this wall. You can even mount it on a face if there is some kind of furniture from where you need to have the supply air. All right. But in this case, the return air diffuser does not have it. The reason being, this family was based to make sure that you can mount it anywhere in the plane. So right now, even if I go to the section and I try to pull it up, it can be pulled up. Make sense? Sure? Do you guys want me to explain it again? Yes? All right. So there are 3 ways to place a face-based family. Now this is a face-based family. Okay, it needs some kind of reference to be placed on. It cannot be just hanging in the air. Many times what happens is if you have a spiral duct, you can have the grill right on top of the spiral duct, right? But over here, this particular family, this one that I was talking about, this requires a face to mount on. All right. That face that we used yesterday was the work plane. Right? We basically artificially simulated a ceiling and reference plane. All right. If we had a ceiling, you can directly actually, if the architect had modeled a ceiling in this floor plan, you could right away go and place it on face over. Okay, wanted, let's say, furniture, and you want to place the diffuser on the furniture. It happens many times in museums. You try to have like art piece, and you want to have our HVAC equipment blend into the art piece. At that time, if you have like a slanted surface, you can mount our diffuser on the slanted surface. Okay, that time also it will come into picture. And this place on vertical will come into picture if your diffuser is mounted on a wall. Is that making sense till now? Yes? Okay. Now, going back to this one does not have that kind of restrictions to it. You can simply drag and place it anywhere you want. But if you check this particular diffuser, you cannot move it. You can move it along this plane, but you cannot move it up and down. You can just move it along this reference plane that we had created, because that diffuser is placed on that reference plane. Is everyone with me till now? Yes, you have a question? Okay, you just all right, stretch it. That's right. Okay. So over here, this diffuser that we have, as we see, it is at 6 feet 5 inches. Let's try to make it a bit more above so that we don't come into any more issues. So let's take it at 7 feet 10 inches. Or we'll do one thing, we'll try to get it in level with the ceiling itself, since we are simulating a ceiling. Now this bottom of face of this ceiling is 8 and around 6 inches above the finished floor. Let's go back to our floor plan. Is everyone with me till now? We went to the section. Initially, when we dragged and dropped this return diffuser, it automatically took it to 0 feet 0 inches. It's fine. We placed it. Then we went lower face of that grill is in line with this reference plane. Since we are trying to simulate it. So if anyone has any questions, please raise your hand, call me to your desk, even online, please let me know. Now, yes. Closed? Wait a minute. What happened? Okay, let's go to the section. All right, so I'll show one more time how I use the return diffuser. how I place the written air diffuser. I'm going to delete diffuser and click over here. Okay. Again, click, hold, drag, and place it over here. Click. Is everyone with me till now? Yes? No? We'll take a 5 minutes break at 4:30. 4:30 in 10 minutes. All right. Everyone doing good? Any help needed? Please call me to your desk if you yeah. Please don't be try to ask me questions again. I will read sometime and learn so many things. Okay. All right. So what has happened over here is that the background has gotten a in here. Right? This is this If I wanted to take option based right. This is what I said. No, this is not. Open that and I will show you when actually it comes to the project, we expect that someone else. You can hire me. So open up Revit but please make sure that you are alright. Any other questions from anyone? Yes, no? Okay. Issues, audio and screen frozen issues providing support to engineers. Okay, all right, yeah. So sorry about that, Lawrence. I was in the room. Okay, so now everyone is with me till this point. click, drag and place. Yes. Click, drag, place, return a diffuser. Yes. Now let's go to the section view. Please make sure that the extent, this is the extent of the section view. The dashed lines are the extent of the section view. You need to have the element that you are trying to view also covered in it. For that, you can click, hold, drag and move the extent of the section view over here. All right. And then go to the view, or else you will not be able to see the diffuser that we are doing. Again, I'll try to reduce the extent and go to the view. It will not be visible since that diffuser is not in the extent of the view. Make sense? All right. Now what we'll do is you can either click on the diffuser, click, hold, drag and move it around, or you can simply click on the diffuser and then move it with the move command tool. Click on the move command tool, select a point and then move it to the ceiling space. Please give me a confirmation once this is done. Done? Everyone else? Done? How about you, sir? Are you following? Please follow. Come on. I need to make sure that you understand why we are doing, how we are doing, because again, day one knowledge is now getting connected by the dots, right? All right. Can we move forward? Yes. All right. So now what we are going to do is, first, we'll make sure that we start drawing a small flex duct. Again, don't make this duct very lengthy, maximum 5 feet. And on return, most of the times you will not find that big of a flex duct as compared to this one. So it is fine if you take it to a small length. Okay. So make sure that the duct basically comes a bit out of that diffuser. Yes. 5:30. We'll just have 5 minutes break. Okay. So right click, flex duct, and make sure it is not. Okay, right click, flex duct, and make sure it is not aligning with the lines over here. The reason being that it's for some reason trying to get it self-connected to itself in a circle. So make sure you have a small return air duct. Okay. Now, one more thing I wanted to point out over here that I did not yesterday. When you click on the diffuser, it will give you the CFM, 80 CFM, 85 CFM. Now, this room is categorized as not required for any type of pressurization between the two areas, correct? So that means if I have 80 CFM or 85 CFM being supplied to the room, on this CFM as well, I can have a 85 or 80 CFM, let's say 80 CFM since I have already typed it. So if I have 80 CFM supplied and 80 CFM returned, we are at neutral pressure, right? Yes. How to balance supply and return? So 80 CFM we are supplying, right? And 80 CFM we are returning. That is making us at neutral pressure. This is by the concept of supply and return. Okay. On field, you'll need to have a butterfly valve, volume damper to adjust the CFM. There will be another contractor called as testing and balancing contractor. They are called TAB, testing and balancing contractor, who will go to each and every diffuser and check how much CFM is coming, try to adjust the volume damper and try to make it 80 CFM. Make sense? Does that answer your question? All right, perfect. Now, going back over here, just one point that I'll make before we go into the break. Everyone, by the way, has the flex duct connected, right? Okay. So now we had spoken about infiltration, right? Yesterday I had drawn the diagram over there. There is ability for the outside air to seep in through the cracks. That's why we provide a bit more CFM so that the infiltration is countered. So if you are supplying 80 CFM And if we return back, let's say only 70 CFM, supply is more than return, the room is positively pressurized. Does that make sense?
Yes.
Now, I have not spoken a lot about this room, the surgery room or operating room. Please pay attention over here for 2 minutes. This room becomes very critical. Always make sure. Now this room as compared to this room, the CFM that you are putting in this room needs to be less as compared to this room. CFM that you're putting in this room, the corridor, needs to be less as compared to this room. Air cannot flow this way into the room. It has to flow outside as compared to the adjacent area. It needs to be positively pressurized. Is everyone understanding the concept of positive, not required, negative pressurization from ASHRAE 170 standard? I see some blank faces. Sir, is it clear to you? Okay. How about back over there? Is the concept clear? Okay. So now over here, we are still going to put 70 CFM because we want the room to be positively pressurized to make sure the infiltration load is not overpowering the internal loads. Okay, we need the extra 10 CFM to seep out. That is fine, but we don't want that other 10 CFM to come out and add to our loads that much. Make sense? Positive pressurization. I know it is not required return. So not required means you can either have it positive or negative. But if there is a restroom right next to it, that restroom needs to be negative. That would make the patient room positive pressurized. Okay. In this case, our logic for positive pressurization was for infiltration. Let's say if this room is somewhere in here, okay, like yesterday, I think so Lawrence or Tony mentioned online, like this room over here is interior room. It does not have any infiltration assigned to it. And if this room was a patient room, it can be at neutral. 70 CFM inlet, 18 CFM inlet, 80 CFM outlet. Make sense? Do you want me to repeat this point? So infiltration only happens when you have external facade, right? Infiltration is the outside air trying to seep in through the cracks between the walls and the floor, right? If you have the room like this admin area over here, which is not exposed to the outside condition, none of the walls, if you check properly, is exposed to the outside condition. So there is no infiltration coming through it. In case that admin room was a patient room, then it would be okay if you supply 80 and return 80. That is the design philosophy that we can assume in this. Did that make sense? Yes? All right. Now you're understanding why we are trying to do all the theory before jumping into this. Okay, then we will have a short. Yes, please. Right. Okay. Right. Okay. So for the folks online, the question in room was, what if the CFM in the operating theater reduces as compared to the CFM in the corridor? In that case, we will have a corridor positive pressure as compared to operating room. Operating room becomes negative pressure in that case. The air will start flowing into the patient, into the surgery room, into the operating room, which is not allowed, right? It needs to be positive. So yes, you are correct. In that case, usually the operating rooms will have a different corridor assigned to it. Okay, that corridor is not readily accessible to the public. It is only accessible to the doctors, nurses, and the patients who are being operated. Okay, so in this case, technically there should be another small corridor over here whose CFM, that is the total air changes per hour, will always be less as compared to the single operating room is total ACTH. Right? So at any given time, the air from the corridor cannot enter into the given particular operating room. Okay, just a minute. I know I have been using this model, but let me give you hospital. Let me give you a better example. So over here, as you see, so over here, I think so these are the operating rooms, and then there are rooms over here. Okay, so over here, this is one OR, this is one OR, this is one OR. Then there is a corridor for that operating rooms. Okay, this corridor is not accessible to any of the guests, any of the visiting thing. Only the doctors who are going to operate, or the nurses who are going to assist, and the patient who is going to be operated can be accessed through this door. Okay, so this area will always have low CFM supply to it, even at the highest possible heat load, as compared to any of these three operating rooms. There you go. Clean corridor. Yes, question. For the operating room? Yes, we do have operating room here. Yes. Operating room will usually have the most CFM pumped into it. But only thing, now, okay, I know I'm pushing the limit over here, Emmanuel, but give me just one moment. Last point. Over here, the supply, so return air grill, we placed it on top, right? In the surgeries, the return air grills are placed on the bottom. I mentioned the other day as well, we want to have a laminar flow, right? Plus the bacteria and the infections are usually heavy, so they settle on the bottom, and that is where the return will go back to the air handling unit. Did that make sense? All right, then let's have a 5-minute bio break for the folks online. Manuel, if you can drive it. All right, so welcome back. Before break, we placed the return air grill. We drew a small connection of flex duct. We spoke about pressurization. We spoke about in actual world how the pressurization will be done for operating rooms. Now what we need to do is, we'll do it for this particular room, for the return. All right, what we need to do is simply start drawing the duct. Now that we have the return air duct flex connection till here, again right click, this time draw duct. All right, right click and draw duct. It will have the return air duct that will be showing on your screen. The size of the return air duct is 12 inches right now, which is fine for now. Excuse me. Let's go ahead and start drawing the duct all the way back to this duct over here. All the way back to the duct that you have over here. From this point, we are trying to return it back to the air handler. These 2 points are going to the air handler. Make sure you draw the return air duct. You place the return air duct, flex duct, and then start drawing the duct all the way back to the pink duct that you see over here. If you don't see it over here, try to get it in this area near the female water closets over here. Everyone with me till now? Yes? Can I get a yes? Yes, yes. Back over there. Are you guys sure you guys are doing this? Please make sure you put the effort. How about yes? Yesterday I told this. Why? You can delete that and bring in the return. Everyone else with me? Okay. Anything? Okay. Try to get the heat in this. Okay. So now that we have the duct, now you see some points where the ducts are intersecting the return air duct, at least on the floor plan, right? We began from this point, we started drawing from here, but we see that there is some overlap over here. We see some overlap over here. We see some overlap over here. Does that make sense? Your ducts might be oriented a bit differently since you tried to do it as a practice, but try to identify the areas where the ducts are overlapping each other. Let me come around the room and check. Oh, you are not in the morning? Okay, all right. All right. Okay, so let's come back. You also have some overlaps. So now the reason that we were talking about all of these overlaps over here is the reason we were talking about is for coordination purpose. Now, if you take a section view and try to go to the location where you have the overlap, go to the view over there, you see now the ducts are clashing with each other, right? So now this is probably going to create more and more RFIs saying that there is no space in the ceiling for it, right? Just like yesterday that we had the selection box, right? I showed you yesterday a selection box. Click, hold, drag, try to select elements over there, go to view, and in here you'll have the selection box. In the selection box, when you see that the ducts over here, this duct and this duct are overlapping each other. Sure. So we identified one overlap over here, right? For now, we'll consider that one. Right now, if I'm looking at that from a, if I'm looking at from a section view, you see that there is an overlap between the two ducts. Alright. If you want to look at it from a 3D view, click, hold, drag, select the equipment that you want to see in that selection view. Go in, this view option will show up. In here, you'll have the selection box. Click on the selection box. You will see these two ducts that are in conflict. Everyone with me till now? Yes? Please make sure you understand this concept. This is a very important concept for coordination. If you send this model to the contractor, rest assured you're going to have a lot many RFIs, lot many shop drawings coming your way. So to avoid your work later on, make sure this is a very minute part of your work time that you will spend in this, that you will save later on during the construction time. Okay, so I've got a question online. No, not yet understood. Please, could you do that again? Okay, so we are going again. I'll close this 3D view and start as good as new. Okay, so now we are talking about the overlaps. Okay, when we are doing a project, as I mentioned over here, in the first day we had some pictures. Like these pictures, right? These pipes over here are not properly coordinated. If we had Revit over here, we could see that the pipe was going through the beam, that the pipes were going through footings, that the pipes were literally going through columns. We could have moved that right away. Something similar is going on our project at this location or this location, where the ducts are now going into one another. If you give this particular drawing to the contractor and they don't give you an RFI, most probably they are going to try to run that duct like that. If it is a good contractor, they will send you the RFIs, they will ask you for further investigation. But we want to make sure that this coordination is also properly done so that when our model goes to the contractor, coordination issues are avoided. All right. For that reason, first of all, we take a look right now from the top view. It looks like that the bottom duct, that is a return air duct, is below the supply air duct. Why? Because it is dashed over here. In mechanical engineering, usually when you have something that is dashed on a floor plan or a plan view, it is usually hidden below the surface that is on the top. Right? Just mechanical engineering concept that we are talking about. Over here, from the plan view, from the top view, it looks like it is coordinated. But when we take a section view over here, we can straight away see that the supply air ducts and the return air ducts are clashing each other. Just as a sanity check, we go to the floor first and we try to take a small 3D view of that particular area. For that reason, we are trying to select this area. We are click, hold, drag. Of this area, I want a 3D view. Excuse me. Excuse me. Thanks. So we take a window over here, click, hold, drag, and leave it. All right, that has selected the particular elements over here. Now you have the view menu activated on the top ribbon over here under the modify category. In here, you have the selection box. Click on that selection box over here, and you will even see in the 3D view that our ducts are colliding with each other. Right? This is the floor above, and the duct, return air duct, is colliding with the supply air duct. Okay, Mr. Tawalkalt, sorry if I'm butchering your name, okay, thank you for the explanation. Perfect, awesome. Now, going back into the level 1 view, we want to make sure we avoid this. Okay. One option is for us to reduce the height of that return air duct or reduce the height of the supply air duct. Okay. Usually the supply air ducts will take priority because they are meant to be passed through the areas without any hindrance because they are carrying conditioned air, right? Cool air. So for that reason, what we'll do is we'll introduce some more fittings in the return air stream so that the return air duct is not in conflict with the supply air duct. So we'll take the same section, we will flip it around, we'll make sure our section extent is only up to this region where we have the actual clash going on, and then we will go to our view over here. Here again it becomes very evident that the supply air duct and the return air ducts are clashing each other. What we can do is we can reduce the height over here of this return air duct, or we can introduce some more fittings. Okay, I will show you how to introduce some more fittings. What we will do is we'll go down like this and come back to the same elevation over here. Okay, of course there is one option of reducing the height over here which will take care of most of the things, but I want to teach you how to have different transitions going on so that you can go up and down as well through the project. So over here what I'll do is I will split that duct into 3 pieces now. Okay, this duct will split it into 3 pieces. For that we have the option of split element over here. Okay, this option is available in the modify ribbon, in the modify section, split element. Click on it, you will have like a cutter that you will see on your cursor. One more time, we are in the section view, we want to turn the duct down and come up. Okay, for that we are going to split the duct at 2 locations, making 3 parts of the duct. For that we will use the split element command, which is under the modify ribbon, modify menu, split element. Everyone is following? Modify ribbon on the top over here. If it is not directly available, click on the modify ribbon. Under the modify ribbon, you will have the split element. Everyone with me? Okay. Now we'll split the duct, return air duct at 2 locations, first and second. Alright, return air duct. Again, if you have done the homework this morning, then you will have some point of reference. So I would recommend that you do the full exercise that was given to you this morning. Everyone with me till now? No? In the section, okay? So this is fine. We will assume that the supply duct is going through in this section. But what we have done is that, okay, we wanted to split that up. What we do is we put it down and below. Alright? Yeah, you can go ahead and split that. You need help? Over here, go ahead and split it. Okay. So over here, so now you can see. Now you see a 3 9 right? Basically, the thickness of it. You can do that, but I would recommend you to split it as well. I wanted to do the split up. Everyone with me till now? Yes, no? Yes?
Online.
Online, or you can type SL on the keyboard. Yes, I'm coming to that. Good point, Peter. Everyone with me? Okay. So let's move forward and let's do one thing. We will remove this duct from here for some time. Okay, we'll delete that duct and then we'll start drawing another duct from the last point over here. So when you split the duct, what Revit did was it assigned something called as a union. Okay, what is a union? Let's say you have a long length of duct, 100 feet of duct. When you order it, it is going to come in 50 feet and 50 feet. But on the floor plan, you'll need to assign it as a 100-foot duct. For that, you'll need to have a union in there. All right. Basically a plate that is joining the two ducts. Is that making sense? Okay. So this is what it is. Okay. Union. So now over here, if you zoom in, if you see from outside, it will look like it's just one connector element. But if you zoom in, there will be two. You right click on it and you'll have the same options over here that you have. We want to draw duct over here. Yes. You have a question or? Split it. Okay. Okay. Yeah. So this is one intricate part of Revit. So Revit will give you option in seeing these lines as thin lines or thick lines. Okay. In case your lines that you see are very thick, there is this option on the top called as thin lines. Once you click on it, your model will show up, your lines will show up thick. Click on it again to make it thin. But please note over here, if you're using this, what will be printed on your paper, on your PDF, will be the thick lines, not the thin lines. So it matters when we are doing printouts. Okay. If you're trying to coordinate something and if you have thin lines, it will be not the thin lines that will get printed. It will be the thick lines like this that will get printed. So please make sure that you understand properly so that the thickness is not missed in the conversation. All right. Is everyone with me till now? Okay. All right. Now let's go ahead and click on the union. Right click, draw duct. Right click on the union. If you don't have a union, that is fine as well. You can just take the duct over here and then draw duct. Yes? All right. Now what we are trying to do is we are going to go with a 45-degree elbow to make sure we do the jump over here. Okay. So you'll start draw duct. Okay. Again, click on the duct, right click, draw duct at 45 degree. Click. Then you have another piece of duct over here. Now you have introduced 245 degree. And now you'll go back again to try to meet the location for this duct. Okay, at 45 degree again. It might give you an error. The error being there is no fitting available in this kind of particular scenario. So you need to adjust your duct over here to make sure that you have the proper given 45 degree radius, 45 degree angle fitting. Did that make sense? Sure. Make sure these coordinations get done properly in your project. Ducts will always create issues. Okay. You'll always have fire protection consultants. You'll always have plumbing consultants running over our ducts. Yes. Right click, water, start 2025, 0, July, 0, July, 4.5. Now go over, zoom in and remove the elements, in case your unions are giving you issues connecting, make sure you delete the unions. Don't use the unions. Is this coordination understood properly? So just like this, make sure you avoid sloped pipes. Okay, sloped pipes will come into picture when we are talking about sanitary waste, soil pipes. As per the codes, you would require to have a minimum slope for the pipes. Whenever you have something that is sloped, if you are working on a restaurant project, there will be grease ducts. Grease ducts are sloped. Yes. Is everyone understanding what needs to be done? Anyone needs any help? Let's move forward then. All right. So, has everyone understood this particular concept of coordination? Please make sure you say no if you have not understood. This is one of the very fundamental aspects of Revit. If we are not doing this in Revit, then we are defeating the purpose of using Revit. Is everyone with me online as well?
You remember the previous question? Which I was saying? No, I just have to slow down. Go again, down. Yeah.
Yes. So Peter, yes, you did. He noted one point regarding keyboard shortcuts. I need to make sure that that is explained to everyone. Okay, coordination. Are we getting the model coordinated? Yes. Okay. So what is happening is, first of all, there is not space. So there is physical constraint, right? So when you have a elbow, as first maximum, you have some radius, right? So if you can keep it on the radius of the proper so there needs to be space when that's what I'll say. We need to have this properly coordinated. Again, if we have this properly coordinated, we don't need to have custom parts. Okay, unnecessarily custom parts will increase the cost of it. So maximum. Okay, are we doing good? Online folks, are we following over here? Okay. So now what I want you to do is do this as a practice for all of the other rooms. Please note, you have the 3D view as well at your command now. Our projects need to be properly coordinated all the time. If these kind of issues happen on the field, of course, that is defeating our purpose of using Revit. We need to have coordination done properly. Now, instead of this blue duct over here that we have, it might be a pipe. It might be conduits. It might be cable tray. It might be another duct as well. Correct? So please make sure that this coordination is done properly. Is my logic correct? Am I getting it right over here? Any questions? Anyone online? Any questions? Okay. Can we move forward now? Yes? All right. Because we are transitioning into electrical now. So make sure you have your questions answered for HVAC. Of course, I'm here tomorrow as well to answer your questions if you have any. But this coordination aspect clear to everyone? Online? Anyone? Okay. All right. Let's move ahead with the electrical portion as well now. All right. All right, so welcome back again. I will start sharing my screen now. Excuse me. So, all right, let's move ahead. Now we are coming into the world of electrical engineering. Till now, of course, we focused on HVAC a lot, and in a typical hospital project, HVAC usually will take a lot of more time as compared to a given electrical or plumbing system. So this is typical of what we are doing. This is not something out of the world that we are doing. All right. So before moving forward with this point, I'd like to get an opinion on the types of electrical devices or something connected to electrical power that you will see in a given hospital. Any feedback on that? Type of electrical devices or any device that requires power in a given hospital? About lights? Circular lighting? Right. Yes, yep. CT scans, yep. X-ray machines, right? Heart rate monitors, right? HVAC systems, of course. Right, exactly, right? So those are the typical devices that we'll be focusing on for a given hospital, right? Okay. So as I was saying, typical equipment that we can find, electrical equipment that we can find in a given hospital. Of course, there is the receptacles, outlets, sockets, plugs, different names. The correct technical name would be receptacle, all right, to where you connect your devices to get power, right? What happens sometimes is there might not be a receptacle, but it will be hardwired, right? The manufacturer might not give a 3-pin or a 2-pin plug, but rather it will be expected for the contractor to take the wires from the equipment, wire from the panel board and just do a pigtail, they call it, right? And then put it. You'll have a junction box in that case, all right? Junction box is something that just sits in the wall. It has a face plate, but internal wirings happen on a junction box, right? Next, of course, the medical equipment. That is one thing that will require power. Life support systems, right? Lighting. Now, let's talk about this other day when I was showing you the news where an unfortunate incident happened, that there was a surgery going on and there was power outage, right? Cannot happen if the surgery is going on in the operating room, right? It needs to have a good emergency backup that you're talking about. So the very common one, I've heard in Kigali, diesel generators are not that common because there is hardly any power outage. That's what I've been told. It's not very common. Maybe someone is smiling from there. I hope that is true. But in my country, in India, power outages maybe happen once a month or twice a month. During that time, the diesel generator take the road, right? But between the power outage and the diesel generator running, there is a time lag, right? Diesel generator does not run right away. It has an automatic transfer switch, which works on the principle of electromagnetism, that will change its direction from the utility to diesel generator when there is a power outage, right? Yeah. That entire process will take anywhere between 1 to 10 seconds. It might be fine if we are doing that over here in the conference hall, but of course, if it is in an operating room, not possible for that kind of scenario to sustain. For that, we require the uninterrupted power supply, UPS. All right. In addition to the DG set, first line of defense for operating rooms when there is a power outage, UPS. All right. Then after 10 seconds, whenever the generator kicks on, that is fine. But for that 10 seconds, we need to have a proper UPS design for the emergency power backup. All right, with me till now? Next. One of the important points regarding the connected load versus demand load. Has anyone come across this lingo before? Connected load versus demand load? Yes? How about you, sir? Right.
Demand load is the actual power, the demand to the source of power.
Correct. Like over here, we have these extension cords or whatever they are called, surge protector extension cord. Out of the 5 outlets, out of the 5 receptacles over there, only 3 might be occupied. 2 are still not occupied, right? But there is possibility of using those, but very rarely, right? For that, we apply a diversity factor to the connected load, basically making sure that we have the proper demand load calculated for a project. All right. Now we will also check when we are doing the exercise, we'll check how do we have the proper demand factor applied to rooms such as operating rooms or operating theaters. Same lingo. Some part of the world they will call it as operating theaters, some part of the world they will call it operating rooms, but then just it will be the same. Patient rooms also we'll check. We'll talk about the X-ray, MRI, CT scan rooms, equipment, so on and so forth. Now, this is where our expertise will come into picture. And this might depend a bit from country to country, plus hospital to hospital as per the requirement of the doctors. All right. So let's talk about the operating rooms. Okay, the very important one, operating rooms. In a given typical operating room, all right, you would require a total of 16 receptacles. Total of 16, 1-6. 8 among them will be connected to the raw power or the utility power. Basically, that will be on the diesel generator set, DG set. Other 8 will be on UPS. Alright? And those that will be on UPS typically will have a green dot or a note on top of it that it is connected to the UPS. Make sense till now? Receptacles. We are talking about these plugs over here. Right? Now, what is connected to these receptacles? Of course, the medical equipment. There might be monitors. So these are the typical equipment that are connected to those receptacles. All right. Next, talking about lighting. Has anyone come across this term called as lux levels? Lux, L-U-X. Lux levels. Luminaire is another name for lighting fixture. This is a luminaire, or also called lighting fixture, or sometimes only called light. Okay. Someone will even call them lamp because there used to be incandescent lamp, just one lamp in given light fixture. So for a given hospital, what is expected is that the lux level need to be somewhere around 800 lux. For an operating room, the recommended lux level are 800 lux.
Yes.
Right? Now, again, we are talking about two parts over here. One is a lux level, and you will also come across foot candle levels. Okay? So lumen, so basically a light fixture, a luminaire will emit lumens. It will be rated for a lumen package. Right? Let's say there is 1000 lumen coming out of it. All right. Lumen upon the unit square meter. All right. Lumen upon unit square meter is the formula for lux. Lumen upon unit square foot is the formula for foot candles. Why do we need this? We need to make sure that what the doctors are seeing. First of all, doctor also have something called as a surgical boom at their disposal. Let me show you the picture. So you might see something like this when it comes to a hospital. These are called surgical booms. There are lights as well in the surgical boom that will let the doctors properly concentrate the light on the area that they are doing the surgery on the patient. All right. In addition to these lights. Okay. So again, over here, this is the patient bed, this is the surgical boom, and then there is more lighting around, right? That lighting we are expected to maintain at 800 lux or 80 foot candle. Again, giving you another example. Over here, these lights are supposed to give out 800 lux or 80 foot candles. 1 foot candle equals to 10 lux. All right. So we'll talk about calculations as well in some time. Okay. So now, as I said, the surgical boom that also has electrical requirements, power requirements. For that, we need to have the junction boxes. That surgical boom will not have a plug assigned to it most probably. most of the time in my career, I have seen it be hardwired. And for that, you would require a junction box. Junction box. Let me show you what a junction box is. So junction box will be something like this. Okay, the wire come in from there and it is hardwired. It was a letdown or what? Okay. So moving forward, there will be LAN sockets in case you have question. In case there are any data devices that require LAN. There will be telephone sockets in case telephones are planned to be used. And of course, there will be TV screen outlet as well. So HDMI outlet or any Cat5 outlet that might be required for the TV might also be there. Okay. So you can take a picture of this on your phone because you will use this to model our project for operating rooms. Okay. Go ahead and take the photos so that we can use that for doing our modeling in Revit. Any questions on that? Oh, sorry. I'll send the PDF copy as well, but take a photo for right now for designing our different rooms. All right. Let's move forward. Another typical room, patient room. Now there are different types of patient rooms, right? If there might be a general ward where there might be typically like 8 to 10 beds. For that, you will require receptacles 2+2. Okay. In the operating room, we had 8+8, right? Over here, we'll have 2+2. 2 on the utility, 2 on the UPS. Lighting, we will need to maintain a minimum of 50 foot candles, around 500 lux. Next, there will be a nurse call button, one nearby the door. Okay. One more point I am missed out over here in the presentation is that receptacle. No, yeah, it's there. Sorry. We need receptacle per bed. So since there are 10 beds, if there are 10 beds in a general ward, there will be a total of 40 receptacles, 4 assigned to each bed. Make sense? So basically 20 will be on the utility raw power and 20 will be on the UPS. Next, there will also be a LAN socket. LAN socket can be right next to the nurse call button, telephone socket, TV screen. All right. So this was for the general ward patient room. You guys can take a picture of this as well if you. All right, moving forward, after the yes. 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 Okay. So the question in-house was usually when we have a patient room, there is like a power strip near the on the wall near the top of the bed that can house multiple outlets. Typically there are the 2+2, but we need to consult with the doctors. What is the plan for that patient room? Is that patient room going to be increased in the future? Any renovations that are going to be there? Any specialty equipment that would require more sockets apart from the 2+2 over here? Based on the consultation with the doctors and the specialty consultant, specialty equipment consultant, because hospital will also have a specialty equipment consultant. These all are specialty equipment. After getting a write-off from them, then we decide. But this will be the bare minimum that we need to have. Make sense? All right. So we are talking about the general ward now. Going to the next one, which is the semi-private. Basically talking about 2 beds in one room. Semi-private, right? In between they will have a curtain. In this case, again, receptacles per bed, 2+2, normal plus UPS. Yes, sir. Sure. Okay. So that's moving now. Yeah, so semi-general. Okay, so the question in house was that we have a gentleman from one of the hospitals where they had a general ward, let's say around 8 beds. Then they renovated it and then they added a wall in between and made it semi-general ward, right? With 4 beds. Okay. The question was how many receptacles are recommended at that time? Same thing, 2+2 per bed. We are talking about per bed. Be it 4 bed, 10 bed, we'll give 2+2 receptacles. All right. Minimum. In case the doctors, when the planning is going on, the planning meetings are going on, if the doctors mention something that is needed on and beyond the 2+2, then we need to take into consideration that as well. All right. Again, lighting stays the same for general ward as well as semi-private ward. Basically, we need around 50-foot candles, which is around 500 lux. There will be just one nurse call button. In the general ward, there was one nurse call button on the door. Over here, the nurse call will be between 2 beds. In your case, if you have 4, you can check if you can have 1 between 2 beds. Okay. But again, you'll have 2, and since it is considered general has its own budget. When we talk about money, if the hospital does have the budget, I would recommend 2 between 1 bed. If not, then you'll have 1 on the door. All right. Next, similar to the general ward, you have a LAN socket, telephone socket, and a TV screen. Please take a picture of this as well. All right, let's move forward. And then when we have a private room, just 1 bed in the room, again 2+2 configuration. Then for the lighting, same thing, 50-foot candles or 500 lux. One nurse call button near the bed, a LAN socket, a telephone socket, and a TV screen socket. All right. Please take a picture of this as well. Everyone has a picture of this? Let's move forward. So now let's talk about the offices. All right, you have doctor's offices. You will have 3 receptacles near the desk. It can be on utility power. This is not something that is life safety issue. You can have 3 receptacles, 2 near his desk, 1 on top for the X-ray reading machine, which will have the light in. And lighting, just like any other office, we need to have a 50-foot candle or 500 lux. And along with that, you'll have a LAN socket, telephone socket, TV screen. If needed, take a picture of this as well. Okay, all good. Let's move forward. Now, first of all, as I mentioned yesterday, when we were talking about the heat loads, please note machines such as MRI and CT scans, they have huge amount of power drop. We are talking somewhere between 30 to 35. So whenever you have a room for MRI or CT scan machine, always make sure that you have it discussed with the doctors, the owners, and the specialty equipment consultant. The reason being, this is a very significant amount of load. Entire buildings sometimes run on this kind of load. Okay, so they need to be properly circuited, and hence we need to make sure that we have taken this into consideration. All right. Now, we had a discussion regarding connected load versus demand load. Okay. So basically, whatever is connected right now, that is typically how much will be connected in a given room. All right. Now, basically, we are talking about the diversity over here. How much diversity we require in our loads. All right. One thing to note about, I'll show you the diversity factors. Okay. Over here, we have the diversity factor of different type of equipment. If it is a lighting load for the light, so basically saying if you have 100 watt as your designed connected load, if you take each and every luminaire, check their wattages, and if it is adding up to 100 wattage, then 100 into 0.59, which is 59, is the diversity, is the demand load that you can consider. All right. So similarly, you have different types of diversity factor. Okay. So basically, the connected load into the diversity equals to the demand load. Is the demand load concept clear? Or do you want me to explain it again? Are you guys sure? Please, some feedback. I can explain it to you again. So let's say this particular projector over here. All right. The projector consumes, let's say, a total of 1000 watt. All right. But do you think the projector is going to run each day, every day of the year, 24 hours? No, right? So there is a diversity to its use. So it is not going to consume 1000 watt all the time, right? Similarly, the lights in this room. Similarly, the AC is in this room. Right? So in that case, we apply a diversity load. As I said, if you count all the wattages of these lights and they add up to 100 watt, the diversity factor you can apply it as 0.59, 59% diversity. So the load, basically you're talking about when we will sizing the transformer for the entire facility, you will take into consideration the demand load, not the connected load. Is that concept clear now? Okay. So now talking about the operating room. As I mentioned, operating rooms are very critical. Rest of the areas you can apply a diversity factor, but no diversity factor for the operating room equipment sizing. You need to have it at 100%. Even if the operating room is expected to run 1 month of a day, 1 day of a month, you have to have 100% as the diversity. You cannot go below what is connected. What is connected is what your UPS will be sized for. All right? Make sense? Okay. Now, with this information, what we will do is we'll go into Revit now and we will start modeling in Revit for the electrical devices. All right, everyone with me? All right. So online, no one has asked any questions, right? Yes.
But we have like same as Ashwood. Standards.
Yes.
Document.
Well, yes, there are some standards. Well, not some. There are a lot of standards. One is the National Electric Code, NEC they call it. NFPA, I think so 72 is National Electric Code. NFPA stands for National Fire Protection Association. Again, US based organization. In addition to that, there is also the Facilities Guideline Institute. So that was in the same presentation that I gave you guys that day as well. So for the Facilities Guideline Institute's guideline, you have the link over here. I've sent you this PDF already. Right? This one. Facility Guideline Institute. All right. Okay. Now coming back to Revit. All right. Now, when we were talking in Revit, we had very beginning when we started the project, we saw there is a mechanical template, electrical template, plumbing template, but we selected the systems template. Why is that the case? Because we want one model for the 3 systems: mechanical, electrical, plumbing. All right. Till now, what we were working on was the mechanical floor plan. All right. Over here, as you see, this particular floor plan that was created was in the discipline of HVAC. All right. That we created in the properties, you could see the sub-discipline was set to HVAC because it was in the HVAC floor plan.
Yeah.
All right. What we need to do is we need to use either the power Okay, for the folks online, what I was mentioning was we have come back into Revit and we are going to apply the knowledge that we have in Revit now. In Revit, what we had, just a minute. Can I continue? Okay. Can I continue?
No problem. If you are unmuted, you continue.
Yes, I'm unmuted.
Okay, continue.
All right. Okay. So for the folks online, what I was explaining over here was right now the floor plan that we have drawn over here was in the HVAC sub-discipline, which is under the mechanical discipline over here. Right? This highlighted floor plan is what we are seeing over here. Right? Now, what we need to do is now we need to work on electrical floor plans. Now, electrical again is split into two. Electrical is split into power and lighting. So you have the lighting floor plan, lighting ceiling plan, right? Similarly, you have the lighting power plans as well. Make sense? Okay. So what I wanted to do is open up the 1-power under the power floor plans over here. Under the electrical, in your project browser, under electrical, it will be under views, bracket discipline, electrical. Then you will need to go down to power. In the power, you will have floor plans. And in the floor plans, you will have 1-power. Is everyone with me till now? All right. Now, what we need to do is we need to start working on the loads that we had for various room, and we will begin from the operating room over here. Okay. In the operating room, we need 8 plus 8. Correct? 8 plus 8 receptacles. Is everyone with me till now? Okay. So now what we need to do is, just like we scroll down into the families over here, right? And we had selected the air terminal family from here. Similarly, you will have something called as the electrical fixtures. Both of those plans you will not be able to see. Okay, coming back over here, in the families you have the electrical fixtures, and in the electrical fixtures you have the duplex fixtures, right? Now this is something that is kind of an I would say I've not seen in a lot of other areas of the world, but this is might be typical of the US. So a duplex means this: there are two outlets in a given frame. Okay, so it is fine if you use this symbol, but just make sure that you have mentioned explicitly that your symbol is for a duplex. If not, let's try to get in a simplex. Simplex means there is just one receptacle, and we just want one receptacle. Okay, so just like yesterday we went to the insert ribbon and we went to load Autodesk family. Click on the load Autodesk family over here. Again, insert ribbon and load Autodesk family. Just like we had for the diffusers yesterday, insert ribbon, load Autodesk family.
Sir.
ribbon, load Autodesk family. Until now? Okay, all right. Now, just like we had searched for a diffuser family yesterday, we will go to the electrical section over here. Electrical section on the left hand side. Click on electrical. I had lost it. Okay. So online, I'm going to repeat the process again. Insert ribbon, load Autodesk family. The reason we are doing this is we do not want a duplex receptacle. We want a simplex. That means there is just one receptacle, one outlet in that family. So we are going to insert ribbon, load Autodesk family. Over here, make sure you have the locale setting properly assigned to United States Imperial. And then click on the electrical. In the electrical, if you scroll down over here, you will see under MEP, under electrical power, you have terminals. All right. Over here, you will see different types of receptacles. Clean receptacle, countertop receptacle, duplex receptacle, the same one that we were looking at. Similarly, you'll have a simplex receptacle over here. Simplex means there will be just one outlet in the receptacle. It will not be something similar to what I showed you over here. Not like this. There will be just one outlet over here. All right. So click on simplex and click on load. Simplex. SIMPLEX. This one. Again showing you insert ribbon, load Autodesk family. Click on electrical. Under the electrical, you will have MEP electrical power. Then you will have the terminals. In the terminals, you will have the receptacle. Select it and click on load. All right. So once that is downloaded, let's go back to our floor plan. Now, just for the ease of knowing, we know that this is a surgical room / operating room. We'll go ahead and make sure we tag it. Right? Surgical room, dispensary, patient room. Right? Now in the surgery room, how many total receptacles we need? Total 16, right? 8 plus 8, right? Now, in this room, we will need to work with the doctors on where to place the receptacles. Okay? They have certain set of procedures that require the receptacle to be on certain walls. Okay? So what we are going to do is, we are going to arrange the receptacles on these two walls and this wall over here. All right. So now go ahead and same like yesterday, click, hold, drag, and on your tooltip, you will have the simplex showing up. Again, click, hold, drag, and you have the simplex showing up. Don't click anywhere. Don't place it yet. I'll show you the next step, what needs to be done. Simplex standard. If it is not showing, click on the plus icon. Click, hold, drag, and it will show on your tooltip. Everyone with me till now? All right. Now, in the placement, we still have the placement from the diffuser showing up because that was the last used type. But in this case, we need to use place on vertical face because we are placing it on a vertical face, that is a wall. In this case, if you hover that wall, first of all, if you are not near a wall, it will not show you anything. When you go towards the wall, it will show you the outlet. Everyone with me till now? All right. So what I want you to do is, now I'm giving you the reins now. We have a total of 16 receptacles, right? One we placed. All right. What I want you to do now is, in Revit, properly divide the receptacles amongst the walls. Let's make total of 16. Okay. So 6 here, 6 here, and then that will make 4 on this wall. 6 receptacles on this wall, 6 receptacles on this wall, and then 4 receptacles on this wall. That makes it 16, right? Yeah. 12 plus 12. 6 receptacles on this wall, 6 receptacles on this wall, 4 receptacles on this wall. Six on this wall, properly evenly spaced. I'll show you one example again. Once you have the device placed, you can right away right click, create similar, and then place the another one. So properly make sure that they are properly placed. A total of six receptacle on this wall, 6 receptacle on this wall, and 4 receptacles on this wall. Make sure you don't place it where there is a door, because of course it will be an open space. The receptacles will be mounted on the wall. 6 receptacles on north wall, 6 receptacles on west wall, 4 receptacles on the south wall.
How much? How many?
Total 16 we need, right?
Yeah.
So 6 plus 6 plus 4. Total 16, right? Am I doing the right math, right? Yes, right? Okay. Or they'll not take me back in India otherwise. Make sure they are properly spaced. Make sure they are not on top of each other. Something similar to what I have shown over here. Everyone able to do this task? Guys, please make sure you apply. I know if you were an electrical engineer, HVAC was not your first thing. But if you are an electrical engineer, please make sure you at least do this exercise. So are they good? Perfect. Yes. Any help needed? Everyone done? Can we move forward? All right. Let's move forward. Okay, there are some points. Are you working? Yes, already. Please, is there a guide where it is stated that 8 plus 8 receptacles should be both on utility in operating? If there is, please refer that. Okay, so Grace had one point online. that is there a document stating 8+8 receptacles should be on the 8 on utility and 8 on UPS. So Grace, as I mentioned earlier, there are a couple of guidelines: NEC, National Electric Code, check the facilities guideline, institutes guidelines. Apart from that, this is also a decision that needs to be confirmed with the owner, the hospitals, the doctors, as well as specialty equipment manufacturer. Sorry, specialty equipment consultant. All right. So let's move forward. What was the next point we had for the operating rooms? So for the operating rooms, apart from the 8+8, we have this one, right? Junction box for surgical boom. It's on the ceiling, right? And it is usually in the center of the surgical room, right? And we need a junction box for it. So let's go ahead and go back to Autodesk node family. Let's go to all results and try to find a junction box over here. Okay. So you see different types of junction boxes over here. Go to insert, load Autodesk family. You have the junction boxes over here. Simply search for it. Go to all results and search for it. I will show you again. Insert ribbon, please pay attention. Insert ribbon, Autodesk family. If you are seeing something like this, click on all results over here. And in this top search button, search for junction box. You'll have all the junction boxes now that will be showing up. Got it? What I want you to do is add this junction box dash load. Junction boxes dash load. Junction boxes dash load. Everyone with me till now? Any help needed? Yes? And now click on load. Need any help? Okay, now that you will have loaded the junction boxes family, you will also have the junction box showing up under your electrical fixtures. Got it? All right. So now what I want you to do is, this junction box is mounted on the ceiling, right? Wherever our diffusers mounted, where were the diffusers mounted yesterday? Where? On the ceiling, right? And how did we create a ceiling yesterday? Reference plane, right? So same way, now I'm going to take a 4-inch square 120-1. This means 4-inch square and a 120 volt. This is a common voltage used in the US. If you are using a metric system, the voltages will also change. But don't worry, we are talking about concepts over here. The same concept can be related to metric systems as well. Click, hold, drag, do not place. You will need to make sure that it gets placed on the ceiling. Once you click on it and then try to check the section for it. On top, you will have the section over here. If you take a section and try to check, you will see, of course, see the ducts that are on top over here. our junction box is down over here. Excuse me. We need to make sure that the junction box is in the ceiling, right? That is where the boom, surgical boom will be mounted. So just like we had raised the return air grill, simply click on that junction box, click on move, select one of the point and move it to the ceiling. All right. Are you following till now? Or do you want me to repeat? Go on the power, click, hold, drag, click over here in the room. Your junction box will show up, but it will show up on the floor. Make sure you move it in the ceiling. Does that make sense? Everyone with me? Okay, everyone with me till now? Can we move forward over here? All right. So we'll move forward and we'll check what the next one was for a hospital. We are done with the junction box. We will show the LAN sockets, telephone sockets, and the TV screen now. All right. Please note, as the technology improves, these three types of outlets have all become Cat5 capable. Basically, what you have for your laptop where you can plug in the data cable, that same outlet can be used for this one. All right. Again, please confirm this with your specialty equipment consultant as well. But most probably you're going to use a Cat5 cable for LAN sockets, telephone sockets, as well as the TV outlets. Okay. All right. So now for doing that, we'll go back to Revit. Again, we'll go to insert, load Autodesk family, insert, load Autodesk family. In here, remove the junction box, search over here. Right. After that, when you come back to the main screen, search for data, DATA. Okay. So over here, you will have the data outlet. Search for data and use the data outlet over here. Got it? Data outlet. Select it and load it. Any questions on this one? Make sure you remove that, what was it earlier? Junction box, search from here, click on cancel and just type in data. I'm giving you this shortcut to make sure that, to make sure you get these results easily. But earlier I wanted to let you know how the tree for the families work over here. Is everyone with me for the data outlet? Do you want me to come to your desk? Please raise your hand. I'll be there. Online? If anyone needs any help, please drop your text. We'll make sure you get it resolved. All right. So I'll take that as a yes. Click on data outlet, click on load. Okay, you might get a message like this. This is very often you will come across this. The reason being Revit is saying that a family with that same name already exists in your project browser. what do you want to do? Do you want to override that existing version, or do you want to keep that override that existing version with this parameter values as well? All right. So if you already have it, be careful when you use this option. The reason being, when you start developing families and you start overwriting the previous data that was in the family, might get erased because you're overwriting it. You have typed in ABC in a document and you have saved it as, let's say, version 1. Okay. Then you open that another file, type in XYZ in it. Earlier we had ABC, this one we have XYZ, and you save as version 1 on the same and you overwrite it. So next time you open that version 1, you will see XYZ, not ABC. Similarly, if you have some data that is stored in your previous families and you overwrite the existing version over here, the data from the previous family will also get overwrite over here. So exercise caution. If you already have the family over here, no need to load it again. All right.
If you already did it.
That's fine. Well, that's fine. The question on in the classroom was fine. The reason being, we have not used the data devices anywhere yet, right? So no harm done. Valid question. All right. So checking for the sorry. Family tree, there will be data devices and data outlet. You'll have the plain data outlet. So based on this, again, you need to click drag. The conversation that was happening in house was regarding a message that Revit will give you if you have some kind of some outlet. Yeah, I'm sharing it. Not yet. Okay. So in this case, we had clicked on the data outlet and we had said load. Revit gave us this particular window which says family already exists. The reason I was explaining so much is because if you have already used that particular family in the project, and if you overwrite that family with a newer family, the data that was on the old family might be at a risk of getting lost. Okay. So always exercise caution before you overwrite the families in Revit. All right. In this case, even if you overwrite it, it is fine because we have not used that data outlet family till now in the project. All right. Now, the next point was we need to have a total of 3 data devices, one for LAN socket, one for telephone socket, and one for the TV screen. So we'll simply go into the project browser. Under the family tree, you have data devices, data outlet, and plane. Simply click drag, and under the placement, make sure you have the place on vertical face selected. All right. As per our discussion, we have a total of 3 data devices we need. All right. So I want you to take this exercise upon yourself and place 3 data devices at the location that you seem feasible. All right. Earlier I had given you where to place the outlets for the simplex outlets. Apply some logic. Where can these units, where can these outlets be reasonable to assign? A total of 3 data outlets in the surgical room. Okay, so data devices mounted. How about you guys? You guys were struggling back over here. Elevation. Good. I'll come to that. So, okay. I've seen in Uganda, technically they are usually they are mounting the outlets a bit low, right? Somewhere around like 1.5 foot, 2 foot, 2 feet, right? But in a given hospital, the plugs are usually at at approachable height. 4 feet. Alright? 4 feet. Right? Now, just like we were adjusting the ducts, you guys remember we adjusted the duct height? We will adjust the receptacle heights as well. So if you go to a section view, you will see these outlets mounted at 1 feet 6 inches above level 1. What we need to change it to is 4 feet. Alright? One more point I'd like to make that I missed out. If you have a device that you are placing, you can simply change it over here while the time of placing as well. You will simply change it at the time of placing as well. Okay? But if not, make sure again, as I was saying, I have at least 2 views when you are working floor plan and a section view, and make sure your devices are mounted at 4 feet. Enough? Data sockets as well at 4 feet. 4 feet above the finished floor. It's approachable. Sorry. It should be approached now. That is what. This is something different that you are using. Oh. 2 feet. Okay. If that is the standard in the country, please go ahead and. Okay. One more point. A good point was made over here. That in Rwanda there is standards that maintain the outlets at 2 feet above the finished floor. It is fine. Sorry. Okay, understood. So whenever you are designing a project, your country's building code laws will take precedence over standards. If you have a law saying that you need to do it this way, you'll need to follow the law of the land. Standards are kind of guidelines for us. They are not building laws or not country laws. Okay. So if you have standards from your country, please follow that. If you are building codes from your country, please follow that first. After that, the standards will come into it. Right?
What is that?
Sorry?
4 feet.
4 feet. 4. All right. So everyone with me regarding the receptacle heights? Yes. All right. So apart from this, we missed out on one point for operating rooms. There is one point that I missed out on operating rooms over here. Can you identify which one it is? Which one? We have done all of these except one in our surgical room right now. All of these except one. Can you identify which one it is? We have placed receptacles, right? We have placed data devices. There is one aspect that we have not added to our electrical model yet. The lights, right? So now, as we had used a power floor plan, right? Now we will use lighting floor plan. So let's go ahead and double click on it. Oh, looks like I was using the lighting floor plan. So in case you see power devices on the lighting plan, it should not happen. Okay. Power devices should be on the power plan, not the lighting plan. This means that the visibility graphics of this particular view are not set properly. So yesterday we came to this particular window over here. This one. We were trying to check the room tags, why they are not showing, right? This is called a visibility graphics. Visibility graphics override. How you access it? Either you hit V key 2 times on your keyboard, VV. Victor, Victor, VV. No, VV. Alright? So V for Victor. Right? And in that, you will have the visibility graphics overrides for this particular floor plan 1 lighting. Okay? If you scroll down, you will have options to see what needs to be hidden and what not. Okay? Since this is a lighting floor plan, I don't want to see any of the data devices or power devices. Okay? So what we'll do is we'll turn off the data devices for this particular floor plan, which is the 1 dash lighting. Along with that, we'll also turn off the electrical fixtures for this 1 dash lighting. Alright? And then once you hit OK, those devices will not be visible on the lighting. Please make sure you're doing this on the lighting floor plan, not the power. We need the power devices, data device on the power floor plans, power layout. Okay. On the lighting, we need to show only lighting fixtures. All right. Now, talking about specifically lighting over here. We are expected to maintain 80-foot candles or 800 lux in this particular operating room. All right. As I had mentioned, lumens upon the area gives us foot candle or lux. In this case, since we are using IP system, we'll have foot candles. But approximately 1 foot candle is 10 lux. Alright, I've written it over there as well. Now what we need to do is we need to mount a light fixture or multiple light fixtures to make sure we have properly analyzed this particular, properly modeled this particular floor plan. Okay. In here, you have different type of light fixtures. You have a 1 foot by 4 foot 120 volt. You have a 2 foot by 2 foot 120 volt, so on and so forth. What we are going to use is 2 foot by 4 foot 120 volt. All right. Again, click, hold, drag, and don't place for 2 minutes. Click, hold, drag, don't place. 2 by 4 120 in the light fixtures. It is already loaded in your project, so you don't need to load it again. 2 into 4 dash 120. Is everyone following? Any questions? Questions? You want any help? Please call me. All good? Work plane. Now this is a recessed one. Please go ahead and place it on the work plane that we had created yesterday. I've let you know how to do it. Placement, I've let you know how to do it. Please try it on your own. Place 4 light fixtures. Place 4 light fixtures. Approximately 1 over here, 1 over here, 1 over here, and 1 over here. Make sure they are properly aligned to each other. Right? Don't randomly place it. Try to make sure that they are properly aligned. 4 light fixtures. 2 by 4, 120. Okay, placement. And make sure we have the correct work plane that we had set. Make sure we have 4 light fixtures. Are you guys following? All good? Nope. Not displaying? Work planes, okay. Yesterday I had told you, after selecting work plane, you need to drop down the box and select reference plane. If you have level 1 selected in your reference plane, on the top, do you see the placement plane over here? Over here, we had spoken about this, the first floor ceiling. You need to have that selected. If you have level 1, level 2, level 3, level 4, level 5, that light fixture will be placed on that level. Make sure it is on the reference plane first floor. Are you guys able to see it now? Everyone following? Please make sure you place you place 4 light fixtures. 1, 2, 3, 4. Make sure they are aligned as well. For the folks online, you have not missed anything. I'm just moving around in the room and trying to explain. Is it visible? I'm also going to get certificate. I'm also getting certificate. I'll sign the certificate.
So there is a question from online.
There is.
This is from Tony Makolo.
Screen and audio lost. Has he sent to you private message?
What could be the issue?
I'm not able to see. Okay, click on it. Okay. Okay, so Tony, I saw your text on Emmanuel's laptop. Looks like you have selected the families for UK systems. Make sure when you are, if you are still available over here, go to insert, load family, and make sure you have United States Imperial, and you can download another same type of family so that you can get the same numbers. But don't worry, it's still the same. The physics stays the same for electrical engineering. It's just the voltages are changing. That is fine as well. All right. So everyone with me now? Okay. So now what I want to teach you guys is the foot candle levels. All right. So what happens? Okay. So this particular light fixture, if I click on one of the light fixture and click on edit type, it will show me the type properties over here. All right. If I scroll down over here, it is giving me a lot of data regarding photometrics, right? Now, if you have a luminaire or light fixture that you are specifying, the manufacturer will give you a cut sheet along with it. It is also called a specification sheet, engineer's catalog, engineer's data, so on and so forth. Okay, data in it will allow us to make informed decisions. All right. The reason I'm going in depth over here is I want you to check over here and try to check how much lumen. Yes, 96 watt is the power, and we are getting 89 lumens per watt. So can you just do a quick calculation how much you get as the lumen? All right, so for the folks online, what we are trying to do over here is we went to the
Share the screen. It's sharing.
share. Okay, so for the folks online, what we are trying to do over here is trying to estimate the lumens from this particular light fixture. So when I go to the edit type, select a light fixture, go to edit type. When you scroll down, you will see the photometric data, right? The photometric data will basically give us an idea about what type of light output can we expect from this particular light fixture, all right? With this data, 96 watts at 89.06 lumen per watt, what we are looking at is a total of 8,549.76 lumens, right? 96 into 89.06. Does that make sense? All right. Now, this is for one light fixture. I asked you to place 4 light fixtures, correct? So now this lumen into 4 is the total lumen that is available in the room, correct? Now lumen upon the area of the room gives us the foot candle or lux level, okay? Since we are using the IP system, it is the foot candle that we'll check, okay? Now let's go ahead and check the area of the room. So we are talking about 18 foot by 15.5 foot. Okay, 279, and we had what, 34,000 something, right? 34,300. 199, 200, right? Divided by how much we had the area? 18 into 15.5. 18 into 15.5. 27. Okay, this is our foot candle level, right? As per the guidelines, how much foot candles we need? Minimum 80 foot candles, minimum. So we are above it, we are fine. Make sense? Has everyone understood the concept of lux level over here? For lux level, it will be the same thing. Lumen divided by the area in square meter will give you lux level. Lumen divided by the area in square foot. Approximately 1 foot candle, 10 lux. Repeat? Sure. So, first of all, we are getting lumens out of every light fixture, right? You add up the lumens throughout the room for every light. Lumen divided by square foot will give you the foot candle, square foot, area, square foot. Lumen divided by square foot, foot candle. Lumen divided by square meter, lux. Okay. Numerator lumen, denominator square meter. All right.
Yes.
So now all of these points covered. All right. Now please give me some time. I know we are 10 minutes above the time, but I want you to understand the concept of the UPS sizing for this particular operating theater. All right. Yes, please. Okay. So now we are talking about 8 outlets that are on UPS, 8 outlets that are on TG side, diesel generator side. All right. To check all of the devices in the devices wherever you are placed, right? This one device, if you go to edit type, it will give you the load. In this case, it is 180 VA, voltage times amperes. All right. Now, this might depend country to country. This is based on the voltage to be 120 volt. All right. I understand in Rwanda, the voltage, excuse me, please. Please, guys, please. I understand that in Rwanda, the voltage rating that is commonly available is 220, correct? And the outlets are how many amperes outlets usually typically? All right. Before we lost the connection over here, I got to know something regarding the standards in Rwanda. For a project that is in Rwanda, the outlet power that we take, sir, if I'm saying this right, maximum 500 watts per outlet, right? Maximum. Okay. Maximum. Okay. So instead of having 220 into 16, instead of having 220 into 16 into the number of outlets, follow the country standards, follow the country codes, which says 500 watt for Rwanda. Okay, maximum. Right. Understood. All right. So as sir mentioned, again, we are looking at 500 watt if the project is in Rwanda. All right. So 500 watt into 8 is what we are going to get for the outlets. All right. Then for lighting, all of the lighting of the operating theater will go on UPS. This will be our connected load. There will be no diversity factor to this. I would recommend even add another buffer of 25% on top of it for sizing your UPS. Right? Am I clear? Because this is a very important concept that we are talking about, and specifically since we have gotten geographic specific information over. We are using 8 outlets for UPS, 8 outlets on utility, correct? Utility you can consider the diversity factor. UPS you cannot consider the diversity factor. Okay, 8 into 500 for Rwanda, right? That will be the connected load for power. 64 into 4 because we have 4 light fixture. That will be for your lighting. And then if you have a junction box for a boom, confirm how much connected load that the surgical boom has for electrical. Add all of those together. That will be your UPS size. I would recommend add all of those together. Add 25% more to it. That will be your UPS size. Sorry? 25%. Add more 25%. So if it is 100 VA, make it 125 VA. Make sense? You have some doubt over there. Looking at VA. You did not get it. Okay. First of all, did you understand the 500 wattage, what we are talking about? Per outlet 500 watt, okay? So on the UPS, we have a total of 8 outlets, right? 500 times 8 is our power requirement for operating theater for the UPS. How many light fixtures we had? 4, right? 4 at 64 watt, right? Four at 96 watt. 4 at 96 watt. It's not 64, it is 96 watt. Right? That is the lighting demand. Now we have placed a surgical boom as well over here. Over here with the junction box. Confirm the load of the surgical boom. It depends. If it is a minor OT, it might be a smaller surgical boom. If it is a major OT, operating theater, it might be a bigger surgical. Can the folks online please mention if you are able to hear me and see my screen, please? Can you check if I'm connected, because I'm not getting a response right now. Folks online, can you please type out if you can hear me and see my screen properly? Yes. Okay. Sorry for the gap. So now, if I can have everyone's attention before we conclude the meeting. So now I have 4 type of light fixtures placed on my floor plan, right? The way that they show up are kind of similar, right? Of course, you can right away identify this one, that this one is like a square, right? If you look closely, you might identify that the width of this one is smaller as compared to this one. But these two look exactly same, right? But if I click on it, this one is a 120 volt and this one is a 277 volt. How do we distinguish between these, right? So now we need to understand regarding tags. Okay, this is something that I was going to cover today, but tomorrow. But this basically identifying every typical unit, basically, be it on the mechanical side with the diffusers, or be it on the electrical side with the light fixtures, or be it on the mechanical side with the ducting as well, right? When we print the floor plan, it will come black and white. Although we are adding color over here, it is going to come black and white. How will we identify how much, what type of duct it is? Right? For that, we will be tagging those light fixtures or ducts. All right. What that means is we'll go in depth tomorrow as well. But in the annotate, you have a tag by category. All right. So tags mean basically we are tagging that light fixture and we'll give it a unique tag. All right. So if this one, I'm tagging it, let's say this one, make it a standard tag, and in here, we'll make it A for right now. We'll call this light fixture A. So we'll talk about circuiting tomorrow, but the thing I was trying to explain was, just like the circuit number tag, we are going to have a light fixture identification tag. Right now, there is a circuit tag over here. If you go to insert, and all again, these are all families. Okay. If you go to insert road families, let's remove the data from here. And in here you have the annotations. Okay. In the annotations, in the electrical, let's try to find out if we have a lighting tag. Okay, so here is the light fixture tag. What we already have in the project is a circuit tag. We'll talk about that as well tomorrow. So over here, if I annotate this one with the light fixture tag, it will show up as A. Okay. The reason I'm mentioning A is if I now, since we are seeing this one is a 120 volt and this one is a 277 volt. All right. If I try to tag this one, the other one, it will not show anything. Okay. But if I go to the edit type over here and change the type mark, let's say to B, which will show me a distinction between this light fixture and this light fixture. Right. Now I have more of A, right? I'll start creating more of A and then we will tag it. So let's create multiple copies of A, and then I think so it was 277 2x4. Okay. Now, again, looking similar, but they are a bit different. Now we are tagging them one by one. Okay. This one A, this one become B. This one is A, this one is A, this one is a B. Okay. B again. But now we also need to make sure we translate this data in a tabular form, right? Like A light fixture, it is a 2x4, 120 volt, 96 wattage, right? When it comes specifically into photometric information, what type of color rendering index it has, what type of color temperature it has, right? These lights are cooler as compared to that light over there, right? That is a warmer light on the wall. This is a cooler light, right? So there will be color temperature difference, right? So this is what is tagging. We'll talk about tagging on the mechanical side as well as plumbing side when we focus on, as well as electrical. And we'll talk about the circuiting as well for electrical. All right. Does that kind of answer your question? I know it's partial answer. Tomorrow we'll build it to one final culmination point. All right. Any other points before we conclude for the day? I think so. It was a good discussion today. I got a good lot of information because electrical is something that keeps on changing as the geographies change. It might be different here. It might be different right next to the next country, right? All right. Any points from the folks online? If you can please put it in the chat. No. Oh, left. Oh, okay. Yeah, we lost the. All right, if that is the case, make sure you save your Revit model before you turn off your laptop so that we can use the same one tomorrow. Yes, you had a point. For electrical? Yes. We will have circuiting done tomorrow, panel boards, and those panel boards will basically sum up the type of loads that we have. That will be used for basically the conductor sizing, basically cable sizing, right? Okay. All right then. Thank you so much again. I will stop sharing. All right. I will leave.
Hello, engineers. This is the end of today's session, and I think everyone has enjoyed the session, but it is not the last. As you remember, we have decided to extend our seminar to Friday from morning 9 a.m. to afternoon 1 p.m. So in that case, I would like to request that everyone must attend on time for the last session tomorrow. So, before we leave the room, there is a task sent to your emails. I think everyone has received a notification, or if not, please check for your emails and do the task assigned to you before you leave the room. For those who are online, I think all of you have completed the task. If you have completed, please left and have a good night. Move to your home, and we stay with those who are in this room. See you tomorrow, 9 a.m. Thank you.